Hey Trig class, here we go with another lesson. It's pretty short. Lesson 8. So good morning, welcome back. I wish this zoomed in closer, but it is what it is. So in lesson 8, 8.1 goes over statements of similarity and just you being able to know that triangles and shapes can be similar. So not really going to do much there. But in 8.A, I'm going to kind of skip. In 8.B, they talk about, and the part we're really going to cover is proportional segments. So for example, I'm just going to jump right in. If I have two parallel lines, and remember I know they're parallel by these little tick marks on them, and then I'm going to have two different transversals. So these that cut through my parallel lines are transversals. So let's say that and you know what, for this type of problem, I'm missing something. Hold on. Oh my bad. There is a third parallel line. So I know they're parallel by these little arrow tick marks on the line. And so they're going to give me two segments. On the left, I have that this inside segment has a length of x plus 1. This inside segment has a length of 13. On the right, this is x plus 4. And on the bottom, this is 19. So if these segments, because of the parallel lines, then I know that these segments have to be proportional. There's a couple ways you can set them up, but I like to just set them up by the sides that they are on. So these two segments have to be proportional, and these two segments have to be proportional. So x plus 1 is to 13 as x plus 4 is to 19. And then from here, I'm going to cross multiply. So 19 times x plus 1 has to be equal to 13 times x plus 4. I like to put the number out front because that's what we're used to seeing when we distribute. Okay, so, and I don't know if it helps, this was my yellow side, this was my green side. Anyways, now I'm going to distribute, so this is 19x plus 19 equals 13x plus, I believe, 52. There should be a plus sign. So if I subtract 13x, I get 6x. If I subtract 19, I got 33. So x equals 33 over 6. That can be reduced to be 11 over 2, or 5.5. Up to you. So really simple. That is on the homework. And I'll talk to you guys about in our next Google Meets, but you've probably noticed the difference between this Saxon book and any others. It doesn't list the sections that the problems are from on your homework. And so we can talk about that, but you will see a problem like this in your homework from this section. So that's pretty much it. I don't think you guys need more practice doing that exact same thing. In 8.C, it's proportional triangles. But it covers, that occurs when we bisect an angle, so angle bisectors and side ratios. So in this section, they cover that if you have bisected an angle, so here's a large triangle. If I bisect this top angle, and they will use tick marks to let you know that two angles are congruent, right? If they use the matching tick marks, then I know those angles are the same. So if this is side A, B, C, D, then what I know is A is proportional to C, as B is proportional to D, and, or I should put, instead of and, I should put or. A is proportional to C as B is proportional to D. And you can use either one. So you can make the tops proportional to the bottom, or you can make like this AC belong in this triangle and BD belong to that triangle. Okay? So we're going to do 2 of those. So example 2, let's say we have a problem looking just like this. You probably don't even need the practice if I already drew the picture for you. And let's say this angle is congruent to that angle. Here's A, B, C, D. So side AB is 10, BC is 15, AD is X, and DC is 12. So I know that BD bisects angle B. So here's how I would set up. One way to set a proportion, 10 is to X. So if I'm going side to side, then that is 15 is to 12. Cross multiply. So 10 times 12 has to be equal to X times 15. So 120 equals 15X. And if I divide, X equals 8. I'm going to do one more like that, just so we're okay with it, and then we will move on. So doesn't matter where that bisected angle is. If my bisected angle is towards the bottom, as long as I mark it with the same tick marks, then I know that those angles are congruent. So I've got A, B, C, and then this segment bisector is D. X, 6, 14, 20. So I'm going to set this one up a little different. In the above, I did the smaller, 10 is to X, as 15 is to 12. Here, I'm going to do the other way you could solve it. So I could say, I'm just going to stay on the bottom. So 6 is the smaller piece on the bottom is to 14. As the smaller side here is to 20. So 6 times 20 has to be proportional to 14 times X. So 120 again equals 14X. So X equals 60 over 7, right? Because I would divide by 14 and reduce. So it's okay if you get fractions, totally fine. You don't have to make them a decimal for me. Now, the only other thing I wanted to cover today is some kind of interesting problems you might get on your homework using crazy random symbols. So the following is concept review. So this is for the problems 29 and 30 in homework. Okay, so this is review. I want to cover this because they kind of throw some crazy stuff at you. So, I think we're on 4. So if A part B equals 3A minus 4B, and A rectangle B equals negative A plus 3B, then part A, find, hey, I'm almost done, maybe like 2 minutes. Find 2 heart minus 1 rectangle 3. Right? Looks crazy. So what this is saying, we're going to be plugging numbers in for A and B. Really, that's all it is. And the shape tells you which function. Now, we need to start with parentheses. All right, parentheses first. So 2 heart negative 1 means that I'm plugging 2 in for A, and this is B. So that would equal 3 times 2 minus 4 times negative 1. Because this is A and this is B. Okay, so 3 times 2 is 6 plus 4 would equal 10. So now I have 10 rectangle 3. This is, again, A and B. Now notice they use this A and B in both equations. So the reason I know that I'm using this function is by the shape. So now I'm plugging these numbers into the rectangle function. So negative 10 plus 3 times B and I get negative 10 plus 9, which equals negative 1. So the answer would be negative 1. In part B, we're going to do one more. Find negative 5, heart, 6, rectangle, negative 3. Okay, again, we're always going to start with parentheses. So think of this as when we worked with functions in Algebra 2. They're just making it kind of crazy with giving us random shapes. But think of it like function notation, like f of x or g of x. The difference is we have two different variables. So I'm going to start with 6 rectangle, negative 3. So that would be negative 6 plus 3 times b. Negative 6 minus 9 is negative 15. So now I have negative 15, whoops. So now I have negative 5, heart, negative 15. So that would mean that would equal 3 times negative 5 minus 4 times negative 15, which would give me negative 15 plus 4 times 15 should be 60, which would give me an answer of 45. Beautiful. All right, so for homework and problem set 8, you're going to skip, and this will be in the book as well. What do I have you guys skip? I think I have you skip 5 through 7, 9, 19, and 22 through 24. You're welcome.